Okay, this video is going to go over the basics for impedances. So a resistor impedes the flow of current. It resists it. This is just like how friction impedes movement. And so a generalization of this is called an impedance. So an impedance is defined using the Laplace transform. So I'm going to say that our impedance Z of S, capital Z of S, is equal to our voltage using the Laplace transform, capital V of S, divided by our current in the Laplace transform, capital I of S in this case. So the impedance can be defined for capacitors and inductors as well, not just resistances. So for a resistor, I think it's pretty obvious what its impedance would be. If we have our resistive voltage is V is equal to I times R, using lower cases for these right now. We take a Laplace transform and we try and get our impedance here. So we just divide by I of S in this case. We end up with V of S over I of S, which is our impedance, is equal to R. So resistance's impedance is its resistance. Now for a capacitor, we know that the voltage is equal to 1 over C times Q. And we also know that Q dot is equal to I. So if we solve for Q of T, that's just the integral of I over time, that's the integral of current over time. Then we solve for our voltage here, which would be 1 over C times that integral of current over time. Take a Laplace transform of this, and the Laplace transform of an integral is 1 over S. So we end up with an impedance of V of S over I of S is equal to 1 over CS, and that is their impedance for a capacitor. Now for an inductor, our voltage is equal to our inductance times the rate of change of current over time. It's derivative with respect to time. So if we take a Laplace transform of this, the Laplace transform of a derivative would just be S. So we have S times I of S times our L, and if we divide by I of S here to get our impedance, we end up with our impedance for an inductance or an inductor being LS. And that covers the basics of impedances.